What's happening, folks? Today I have Kevin Carroll with me. He's the BIM director at MKA Structural Engineers. And he's been in the company for more than 8 years now, and he has been working in the BIM industry since 1989. So I'm super excited about this because Kevin has been an early adopter of everything about BIM, everything about the advancements that construction is going through. And I'm going to be talking a lot about BIM and the intersection of AI in construction. So I'm super excited for this one. Thanks a lot for joining, Kevin.
Thank you. Welcome.
Let's start with what is BIM. I did cover a little bit about that, but can you explain that?
Sure. BIM, obviously building information modeling. It's a methodology of taking the models that we might produce of our projects and integrating information into each piece so that as opposed to drawing a line which represents a wall, we are essentially drawing a wall. And so that wall understands its dimensions, its volume, perhaps its finished material, or its structural components inside. So you can add a lot of data to objects in BIM, and that data allows us to extract information to make it more useful to creating the construction sets.
Yeah, and for those of you who don't understand this, it's basically an integral part of every construction project out there nowadays. BIM is an active area wherein people are trying to figure out how can we add more data to all the drawings that we get from architects. So that gives us a lot of like metadata that we can actually build off of. Talk about architects. Kevin, you are an architect.
Yes.
How long you have been an architect for now?
My first job started in 1988 after school, and a few years later I got licensed in California, and so ever since.
Yeah. So can I ask why architecture?
I think like a lot of folks, I had an art background and I was good enough at math, liked sciences, and took a drafting class in high school. And that appealed to me. And so I went for it and got through college and started a career. There's a lot of things visually about architecture that are very appealing to me personally. And so being amongst professionals creating these projects and beautiful spaces was really exciting.
Yeah. And what was about that visual appeal that was very exciting to you?
I think there's if you take a look at graphic design, often you'll find there's a composition, a stability, and a beauty in how a really nice poster is done, so to speak. And when you look at those, you're able to find a inspiration inside them. If you take that poster and the graphics that are created with it and expand that into 3 dimensions, you can then create a sculpture. If you then take the inside of that sculpture and create space, a place for people to exist, move, and circulate, you can then create the art of the architecture on the inside of the space. And so architecture has a way of integrating a lot of different portions of the arts. In some cases, with the right architect, you can find music and classical arts, painting, and even ballet within architecture itself. And so it's an expression that can be vast, and it can be very simple depending on the skill of the architect.
Yeah, it's interesting how you go to different buildings and every architect who drew that building has took some inspiration from their own personal life or something around the neighborhood, and it's kind of like you can see it in the building. For example, if you go like by the Interbay area in Seattle, you'll find a lot of buildings which are like crane structure.
Mm-hmm.
So it's like an inspiration taken from the port around. And
I was always very inspired by vernacular architecture. So if you're in the mountains in Colorado or another place where there's mining buildings, and those mining buildings were in their own right really beautiful because there is certainly form follows function. And so a lot of buildings in context can take their cues from what's around them and what they're meant to do and the history of the area.
So I'm going to ask like a very a blunt question, because it seems like what you're describing is very creative. Of course, it's very creative because it's like an artist, right? And like you have to imagine a lot of spaces, and you have to imagine like how everything fits together and how the facade is looking. But I've also seen the personality of a lot of architects are like very logical in a way. It's like, because in a way you are working in spaces, so everything is like have to sit in these spaces, so you kind of like have to have that analytical brain. Would you say that that's more fact, or is it like, oh no, I think architects are very artistic in nature?
I think it's both, and I think the balance has to be there to be successful. The inspiration from art and the creativity side, has to give rise to how we then take that form and create the methodology for building it. So structure and the rationale of how a building holds up and is able to be stable is very rational. There's not a lot of art in gravity. And so so you have to integrate the reality of the infrastructure of the building. And so that pulls you back to reality. And so, but there has to be a balance, because as you go through the ebb and flow of pushing the art part and integrating infrastructure, there's a constant back and forth between the right side and left side of the brain. And sometimes the architect within themselves is able to flip-flop. And the other times it's really fun to watch as a team comes together to provide the balance within in order to say, hey, let's incorporate this or that, or respond in this way so that we can incorporate all of the things mechanically or electrically or structurally to make the building a success. And so that's collaborative. It's a very collaborative effort. And that's sort of teaming in architecture, right? So you have a bigger building, you have structural engineers, mechanical engineers, interior designers, civil. And in that team, everyone works together to push the design goals within the framework of what they are responsible for. So, the interior designer will have their input as much as the structural engineer and the mechanical engineer and so on. And that provides that rationale that sort of helps the architect who's in charge of the whole project, right? So they don't have to know everything. I was told that you don't have to know everything, you just have to know who to ask. And so those people are the folks that you've chosen to hire to consult to the project. And so you listen to them and you work with them to make the design successful. But the architect has the vision, and that vision needs to be pushed forward. And the successful project says, we pushed this concept forward, but we also were able to incorporate collaboratively all of the infrastructure inside the building together harmoniously to make a successful project.
Gotcha. Yeah, it's a very collaborative and team effort in a way. Let me ask this. So you started off as an architect, but then you moved to BIM. Why was that move, and what did you see coming?
So when I started in architecture, we were hand drafting. And shortly after that, I was trained using Intergraph, which became MicroStation, and in AutoCAD. And in those days, it was very different than how we do our work now. It's very much more simplified. But there was a spark inside that system that was very exciting to me, that I had a lot of affinity towards. And so I was always pushing how to use those things better. Late 90s came along, and we started to see companies come up with ways of doing it that would be called towards BIM. There was an old product called Cative, which in AutoCAD, if anybody out there is aware of AutoCAD, in reference to BIM, you would draw a line in plan which represented a wall. And when you went to 3D mode, it then took the information in that line and said, I'm a wall and I have these characteristics. And so it like built it every time you went into 3D. the windows and everything. And so it was crude BIM, but it was BIM. And I think the thing about it that made BIM the answer for me was their philosophy, which is draw it once. And so that stuck with me. It still is sticking with me today. Take the time to draw it right once and then reap the rewards of having the downstream benefits. So in our case, nowadays with BIM, we draw a column or a wall or a door, and we're able to get elevations and sections and details derived from that information. So if we do it right once, we can get a lot of things around it to help us construct the set of drawings. And that was super exciting to me. When I saw that, man, my heart was just going. And my boss and I at the time thought, yeah, I don't think we thought that this was the ultimate answer, but that software called Cative definitely pushed us down the road. And the continuation of that became Autodesk Architecture, or Architectural Desktop, which had similar qualities, but it was much more elegant. But I think, so you were asking why BIM management. So I was always on the forefront of that, and I really believed in that. And so one way or another in the companies I was working with up until 2010, I was the lead in charge of understanding how to use that technology. And then in 2010, I took the sideways step to become a BIM manager. And I think that a lot of BIM managers in my age range grew up with CAD. And with CAD came also the understanding of how PCs worked. There was sort of a symbiotic thing of, if you knew how to use CAD, you probably knew how to use PCs at a higher level. Or because you knew CAD, you were involved in possibly installing it at times as a CAD manager or as a BIM, and then on into BIM. And what I'm getting at is that was me. I geeked out on PCs and installing software, understanding the OS and things like that, which combined with the drive that I had for drawing it once and seeing things in 3D made it a natural for me to move towards BIM management. The other thing that I found was there's a small slice in the industry of folks who think systematically about production and procedures. And that was me. Back in the old days in AutoCAD, we used to count keystrokes to see what the shortest possible path was to some maneuver in AutoCAD. And we would compare, me and the other guys who really looked at and it was sort of a challenge, a personal challenge, was to do it faster than anybody else. And what I saw was, okay, I know this way that I'm doing it is probably the best way. And it was very much important to me to find ways of communicating that to other people. Today, that's what BIM managers should do. We teach people how the most effective way of using the tool for whatever type of projects they're working on. So I think for me, all the parts and pieces were there to make an effective BIM manager. Eventually, as I switched to my current role, I took that role because I wanted to manage people. BIM managers tend to be on an island. They tend to be the only person in the company charged with standards, sometimes procedures, Revit families. And then there's the whole other part is coding, visualization, and all of the software that flows around BIM tends to fall into the lap of the BIM manager. And but now understanding that and having a really good feeling for how we do production, what are the important parts of how BIM affects our industry, and all of that, plus the fact that I wanted to take the lessons that I learned in the industry as an employee and apply them to managing other people. And so I realized that was a long-winded reply, but there's the technology, the process, procedures and standards, and the attitude of BIM. I want to pre-build this building. I want to design it in 3D so that that same object that I drew helps me create a rendering, helps me do a thermal study, helps do an acoustic study, a site study, and all of that together.
So you've been an early adopter of BIM and like 3D modeling from a long time. And what challenges did you face? Because architecture and construction industry tends to be very conservative in terms of adopting technology. And I'm pretty sure you might have faced some struggles in people like, oh, well, it doesn't work. We would prefer rather paper route and drawing actually everything. Or like, okay, well, 3D modeling, we don't understand this. This is very complicated. What were some of these challenges and how did you overcome those?
We faced those challenges. I faced those challenges all the way through my entire career. We went from hand drafting to AutoCAD fairly abruptly. And I ended up in a group that was using AutoCAD at the first company I worked at. And people around us sort of would give us these sideways glances saying, like, what are you doing? You know, it's just a fad. And we knew that it wasn't. This was just the way we were going to be working, you know, from here on out. And in the early days, I didn't have to fight it because either ultimately my boss or the company itself knew that this is where things were going. And so that's what was going to happen. But within that, there's always the people who adopt in a more slow or methodical way. And there's folks that push, and there's folks that are on the bleeding edge, cutting edge, and further. And so there is always a spectrum of involvement or resistance. And there's levels to resistance. There's resistance because my boss is resistant, so I'm going to follow his lead. Or there's resistance because I just don't like it and I don't want to do it. And then there's all sorts of levels to the personalities of the people that you might work with resistance alone. Just there's studies done on adoption and resistance, and how that manifests itself in the companies that I worked in was, how do we keep getting better? And many people said, listen, we're already doing this right now. Why do we have to worry about doing less keystrokes? Or, you know, so what if you can write a little thing called a Lisp routine, which is what we used to write shortcuts in AutoCAD. Why do we need to spend time doing that when we're obviously drafting right now? You know, old school, there was very few ways to speed up drafting. You know, you couldn't really scale it on a personal level.
Yeah. So let me ask this question to you. I know you started using these advancements in technology in like AutoCAD and then BIM early on. And so when were you able to convince people that, hey, this actually works and it's going to save a lot of time? So number one, were there like instances where you were saving a lot of time than normal architect who was not using this technology? And also, when did people realize that, okay, well, this is going to be beneficial and we can save and we can be very productive?
In the beginning, generally speaking, the way it worked was somehow exciting the people who made decisions about how it could work in order to gain a pilot project. And you do the pilot project successfully and you present that to others and you say, this is how we did it on this one. We think that we have increases in speed coming as we get better at the software. But as we drew it, especially in BIM, with Revit, we drew it and modified it. It automatically modified elevations and sections. And generally speaking, the folks who were doing production saw that as an advantage. What they didn't see or what they resisted was just having to change. It wasn't that they couldn't understand that it was better. It's that they just didn't really want to change to get there. Yeah. So in all cases, someone had to step up and say, this is how you can do it. And you had to prove it. So all along, it was always proving it, not necessarily on the company scale, you had to prove it. With your boss or somebody who already trusted me, in this case, it was, hey, let's give this a shot because I think this is where everything's going. And so it's always the pilots, always.
Yeah, totally. I mean, and it all also depends on who is in charge and how much flexibility they're allowing their employees and co-workers to make these advancements, and how much
Mhm.
trust do they have?
Yes.
So there's a big conversation between how you have 2D drawings, which has been, once architects draw the 2D drawing with the help of Revit or whatever software you can imagine, then those are sent to the construction people who actually draw based off the construction 2D drawings, right? You call them construction documents. So nowadays people have been very skeptical about just the 2D drawings, because the 2D drawings themselves don't give that much details that we can use to actually construct buildings. You need much more specific, accurate details, which usually in 2D drawings it's not found, or you need like much more fabrication drawings to actually produce, for example, steel work. So there's also a concept of like, okay, well, then you have an inbuilt team within the construction team, which is like the BIM team, which draws a 3D model of based off of the 2D construction drawings that architect sends. So then I see from their perspective like, okay, well, they're taking that much effort. It takes a lot of time to make these 3D models. So all that time, in my perspective, you can save it, because these 2D drawings are constructed by the architects using the Revit, which is the 3D modeling software. So then why is there a disconnect here, and why do we have to rely on just the 2D construction drawings being a liaison? I know that government uses 2D drawings, but at the same time, is there a vision when you can actually go directly from that Revit software 3D model that you have created to the BIM model that construction people are making?
You can. And the closest that we have generally today is the delivery method called IPD, Integrated Project Delivery. And IPD says we're going to change the contract for this work to put everybody on the same equal footing, that the team is to work together in order to participate in the rewards of coming in less expensive and participate in the failure of coming in more expensive. And that's an overgeneralization. But what it means is when you go into IPD, the team is the team. So there isn't really anyone to sue if there's a problem or to point the finger at, because the intent of IPD was to come together as a team in the first place.
And what do you mean by team? Is it like just the architects, or the construction team and architecture team both coming together?
Construction, architecture, MEP, everybody. I mean, everybody, all the way down into getting into fabrication. So in IPD, it's common to have the concept of called the big room. During design, you would have a big room or space dedicated to one project with all the players in it. So in that room, you had representatives from the architects, structural, electrical, and so on. And the intent is that you're there to work as a team to get the work done. But also, if you have a question, you can turn around and ask the engineer, is this going to work? And they say no. So you don't waste time, presenting that and having to go through, I'll get back to you in a week, right? No, you turn around and get the answer right now and move on or stop. So that's the procedural workflow part of IPD. The intent of IPD is that the model is the deliverable. Therefore, we're not looking at taking that model and rebuilding it for construction. Therefore, you've saved that effort of going from design to construction, building a second model. And I know that you didn't specifically cover that, but the architecture team, the design team will create a model as the design model, and the contractor will create a construction model from that model called the federated model. And it's like, well, why are we doing it twice? The BIM side of me says we've got to get away from that, because that seems like a waste. But there is value in QA. When the contractor starts modeling based on the documents that the design team has made, they're able to hone in on weaknesses in the drawings and address those via, pre-con and looking at, anything from clash detection to, conflicts, large conflicts. There's a lot of different things that could come up while building that model. So it's not such a bad thing. And in a lot of cases, we do not have a mechanism to not do that. The contractor says, we're going to build this project for this cost. And they, at that time, have taken over the responsibility for the the construction model. And how can they take 100% responsibility via BIM if they didn't have an influence on how that model was built in the first place? So building the second model gives them the opportunity to flesh out the entire model as designed. And so it's not such a bad thing. I believe that eventually we will merge those responsibilities between construction and design so that we can reduce the duplicate costs.
And how can we do that? Specifically, because you mentioned about that you still have to do the QA, you still have to do the request for information. There's much more information that still have to be added to the drawings after the fact. And then, you still have to have the ownership. So how do we achieve merging these design models and then the fabricated models?
So it is happening at small scale. So, your MEP and conduits and things like that are going direct to fabrication off of the BIM models. And we are entering into an age where we can go direct to digital with connection design on steel. And as the capability grows from within Revit, essentially, of getting to fabrication systems, like we need to talk to them better. And as that grows, we can bring in that part of coordination more closely into the design. And there's a lot of challenges within that. If you can get everybody in the same room, like an IPD, everybody can have a say-so on how the models are being produced. And then they can have an influence on the final product. That would be great. But you can't just bring a fabricator into schematic design or design development and say, give us some feedback on this stuff, because you're not ready. The intent isn't to be at that level of detail that you could bring a fabricator in and have them give you really, really valid feedback with which you would change your model. So there's a conundrum. We want all the capability that comes with a truly integrated model later. We want it earlier, but we can't get there because we're designing. We're designing quickly and we're moving things fast in order to respond to the design, the designer, or the client's wishes. And so there's a natural moment in time where you can begin to bring in that detailed information, but it's not even in necessarily even in DD. A lot of our projects, 3/4 of the way through DD, we start constructability review. So where we're doing clash detection and we're trying to find out where we have interference between major systems or minor.
Is that when construction team is also involved, or is it just design?
Usually if we're doing constructability review, it's led by the contractor and someone on their BIM team. So how do we get there, right? I don't know. And I know that maybe that's a cop-out, but we have to bring the entire team together more quickly before the final design goes out.
I 100% agree with that. I have worked with architecture companies for 2 years, and I've ever since I've worked in construction companies, and I'm like, all of these parties are doing their own thing, but at the same time there's no like a desired output because they are like just working in silos and they don't understand each other, and they're kind of like blaming each other in a way, which
That's right.
which should be solved. And I think the integrated project delivery can potentially solve a lot of it, because you're inviting the construction team way early on when the concepts and the designs are just getting started.
It's a really big challenge. IPD takes a level of commitment that most companies aren't willing to do.
What kind of commitments?
you have to commit to the entire process. Your contracts are different. Your lawyer has to be on board with you as a company being part of an IPD process. I worked for companies in the past that the lawyer said, as long as I'm your lawyer, you will not be doing IPD.
Why is that?
Because there's less mechanisms with which to sue for damages when they're real. I'm not saying, and that's why we go into the project, is to look for ways of doing that. But sometimes for reasons outside a consultant's control, something happens and there's an error, and that error propagates to, changes and expensive problems in a project. And if you're the architect and that consultant did that and it affected you, sometimes we have to sue for damages. Anyway, what I'm getting at is, in IPD, you don't do it. You don't have a mechanism with which to do that, because essentially in IPD, you're all the same entity. And you've come together to truly be a team, and you have to all, buck up and figure it out, not sue each other. Lawyers don't like that. Lawyers like to be able to figure out who to sue when there's a problem.
Interesting.
And I know that sounds really negative, and it kind of is. We live in a litigious environment, and the contracts as written, the base contracts from the AIA that, most of the projects are based on, are written to protect both entities. All the entities, the consultants, the owner, and everybody, in a way that makes it possible to protect each other's rights. And IPD is a whole other thing. It's if you're into BIM, IPD is the way, but there's a lot of practical challenges with IPD and IPD has been used as a project delivery method for late 2008, 9, 10, 11, in that range. They started really happening, and there's been a lot of very great examples of how that worked well, and they work well, especially on more complicated projects. And because you really need everybody to come together to draw it once, build it once. And so I don't want to go on the deep end about IPD. It's something that you should read about and understand that there's some really great examples of how it can really bring the team together. But there's more challenges than just saying we're going to do IPD.
Yeah.
It's a big deal.
Yeah. Seems like one of those, early adoption things that, the sooner you get into IPDs, because there are a lot of challenges, I'm pretty sure over time, these challenges will be resolved in a way, at least people can come into one room and solve these big complex problems. And understand the importance of this.
It's a commitment.
Yeah.
But it's a commitment usually based on quality.
Yeah.
Right?
How much do you think is reliant on the owner? Because I think that if the owner decides that, hey, you guys have to work together to deliver my project with this budget and this is complications that we have to face, but we'll make it happen. Do you think that if that happens, then we have chance, and then even lawyers will have to work around it?
Yes. There's a tremendous piece that is on the owner to demand that delivery method, or at least agree to it and be a party to it, right, without pulling out. So it's a commitment, like, this is the way we're going to do it, and the owner in that case has to do their part too, and it's written how you do these things. Just like, I don't know if you're aware of ISO 19650. It's a new method for enabling data within the project and the project teams to be structured in a way that anybody could always be able to go see a project and go to the exact spot for data. Okay. ISO has been working on that, came from the British Standards Institute, and I don't want to get too far into the weeds on that one, but that requires structure. You have official information, electronic information requests. You have people who are in charge of getting requests of information from the owner, from the architect to the team, and it's an official flow of information. It's an official way of mapping out how everything is named, how everything is structured. It's brilliant. It's intense. And in that system, the owner has to be very much into it because they're going to have to respond to information requests. And without it, the team can't do their work. So the owner has to be ready to go. Okay. It's not that much different in IPD because in order for a bunch of people to get it going together in a big room, the information has to be there. You can't be waiting a 2-week delay in getting geotech information. It's got, so there's guidance on timing. And a big part of that is what the owner is responsible to supply. And they also have to supply decision making at the right pace.
Exactly.
So it is absolutely everybody's joined to get it done.
Yeah. So since we're talking about the IPD, and I know that there's gonna be a scenario when you have the design team and the construction team come together, and then you'll have directly be working on the 3D models, and you'll be less working on the 2D drawings. But then you talk about the government and their regulations. They're pretty outdated in a way that they're still relying on the 2D drawings, and not a lot of reviewers in the government entities know how to use these 3D models. Do you foresee that in a future that they will also change to these situations, or they're going to be moving towards reviewing 3D models rather than 2D drawings?
We produce 2D PDFs and prints as our deliverable, unless you're doing IPD. And even within IPD, you're going to be delivering a 2D deliverable for permit review. The system as it's designed today, in order to get a permit, requires 2D information. And it's going to be there for a while, because how would a reviewer review the model in a systematic way that allows them to do their job? I'm not sure. It's my opinion that when the moment that changes is when we've dropped 2D completely from construction. I think your audience probably has seen or is aware that a contractor uses iPads and other tablet devices out in construction. But even then, they're looking at the PDF set to do their job. They don't have to. They can also pull up 3D. My opinion is that as part of AI and the push, ultimately, some company is going to produce the framework to have the 3D model be the basis for installation, arrangement, layout, and everything that the contractor needs to build is going to be based on that. It's an interface, right? The interface would be able to see three-dimensional details in a way that gives the constructor the information that they need in that moment to do what they need to do. But it will be able to switch gears to a different constructor that needs to do construction on a different part of the building, because the interface itself says, we're trying to build this. You're not going to have to look at 2D details to do this. I'm going to be written so that I can give you the information you need as needed, just in time. And that's when we've made the departure away from doing 2D detail work, right? 2D details are written and drawn and drafted in a way that is sort of a set of rules based on, we didn't have a better way of doing it 120 years ago, right? It's old. A system will have to be made that's a new interface that is able to completely eliminate how we see details today. That's when, if we have that system, if we can just insert a fully done three-dimensional model from Revit into the interface system in order to construct, then we will be able to give that three-dimensional information to the permitter to use in their interface that allows them to check. And so, but until we've gotten there, we're not going to be able to do that, in my mind. There will be no reason for a official entity, a local jurisdiction of any sort, to do anything but check 2D, unless there is a verifiable and trustworthy interface for them for a three-dimensional project to do their jobs. It will have to, I mean, think about the complexity needed for them to be able to switch to just three-dimensional checking of some sort is
Complicated.
It's massively complicated.
Yeah.
It's more complicated, I think, than just getting it to work for construction.
Yeah, plus educating the reviewers and like having that system in place so that everybody does that. That's like, we're talking government bodies. I mean,
Yeah.
they are the one of the last ones to adopt things, and
Yet, Corps of Engineer work and GSA work has had a BIM requirement since 2010, I think, or even earlier. And they, without the GSA and without the Corps of Engineers, we would not be where we are today. With
what is the
BIM.
GSA?
General Services Administration.
Mm-hmm.
So General Services Administration will be the owner, I think you would call it, of government buildings that are maybe offices or generalized buildings. The Corps, in conjunction as the government entity, will often be the project manager for military projects. So the Corps says it's not just Army. The Corps will come in and be the representative of the government in order to, and the Corps has their own set of specifications on how everything is done. They have requirements for the drawings, they have requirements for the BIM models, and so does the GSA. And they've been doing it for a long time. It doesn't mean that they actually used the BIM models or ever opened them, but there's been a requirement for a long time to provide those models. Whether it was, and the BIM model could be Revit, it could have been MicroStation.
Yeah, I see. So I know you briefly covered about AI and how this interface can help AI, but could you talk about how you see AI helping architects, structural engineers, and contractors in a way?
I think that you're going to see stages of AI. Currently, AI is being used mostly in architecture, where we can have generative type AI assist an architect to do planning. If you're doing apartment buildings or you're doing condominium design, you can say, I need this unit mix on each floor, and it will produce a design. It's kind of like doing parking lot. It does parking lot design too. It's really good at that. Yeah. But it hasn't expanded into a lot of other parts of the design team as much as it has visually. Like as we all know, AI generated imagery is really, really pretty good. And so it's affecting our rendering programs. It's affecting other imagery generation. And so it's there, right? It is helping right now. When you start spreading to other parts of what we do as a business, it's not quite there yet. As a business, what I mean is building design business. On the structural side, AI, it's going to take longer depending on the type of structures that you do or how crafted the structure is. I think at some point in time, if you're doing very regular, very repeatable designs, say the typical 2-story office building in an industrial park, I think you'll see projects like that being crafted with AI sooner than you would see a 100-story building go up, because of the ultimate crafting it takes to get the design right for structure on a building like that. So what happens in the meantime? In the meantime, AI can assist the production of those models and of the drawings by assisting with, which my big thing is annotation. We do 3D models really well, but annotation requires somebody that knows how to spell. It requires somebody that understands how the industry needs that information to be input. And that part of it, I believe, is going to be one of the first frontiers of things that AI is going to assist with.
How much time do you think it can save if the annotation part becomes automated?
I think conservatively 25% of production.
Wow.
And I would say that, for what we do, half of our time is spent in some annotative task.
And by annotation, you mean like, okay, well, this is wall for whatever that wall is, and then you name, this is wall A, wall B, wall C, and then you have 100 different walls and 100 different windows, so you are annotating all of them in a way.
Yeah, if you're using Revit, it's really a tagging exercise at that point.
Mm-hmm.
And then there's general notes, and there's text that we would add when doing a detail, one way or another. There's lots of ways of getting at that, but some way, somehow, the advancements in AI I believe, need to affect that first. Period. It's not going to be able to say that this beam needs to be this size because you've done it 100 times. We need to know that that beam is sized because of the forces that are on that beam, and that's it. So there is a calculation, and it's done, once or not very often needed to be able to size that beam.
But then if that's the case, then shouldn't you think that can be automated, because you already know that if this is the force, this is the type of beam you need, and you can just automate that, so you know exactly what all structural elements you need for the most part of the foundation, for example, or floors.
In some ways, we kind of already have that. It's our analysis programs.
Mm-hmm.
But AI is going to come in as an artificial intelligent entity, so to speak, assisting, is going to use a different methodology for why that beam is the way it is. In terms of, if you've trained your AI that situationally things tend to be this way, then the AI is going to say, I recognize that this is one of those situations, and I think it could be this. That could help in the beginning, but at some point, at some time, somebody has to say, I know exactly what that beam is because of this calculation.
Yeah.
So brute forcing that if you say that can't something just do that faster? Yes. Then all we need is a faster computer, right? That can do calculations faster.
Yeah.
Or can whip through a building doing all the calculations faster, given, whatever analysis program you have. Because we already have that.
Yeah. Yeah, because in my mind, like, let's say suppose you have the basic architecture of the building, and then the architect goes to a structural engineer. We're like, all right, well, I'm assuming the architect and structural engineer both work together. But in case you have the basic concept of the architect's model, and then you go to the structural engineer, and then there should be some way wherein, like, okay, well, these are the walls, this is the type of wood walls or concrete walls, and exactly like the width of it, height of it, how much it weighs. Then I'm seeing more of this as like, okay, well, you can just take it right from the get-go of when these concepts start, and then you can add on weights as you add more elements, and then the structural part seems to be pretty straightforward in terms of the automation, because you have all the elements already with their weights and their dimensions.
I would agree that part is straightforward. The challenge is going to be what methodology and how we train AI.
So what you're saying, or I guess what I'm hearing, is that first step would be for us to like augment AI in all the processes that we do, start from the get-go of like just having a concept of a building, to actually drawing it, to the structural people who actually use again AI to do some calculations or just help him assist with the structural details, and then you have the contractors who use those in their own augmented way. So I wanted to ask, I know you are an architect, you have seen so much of the BIM advancements past 20 years or more. What other part of architecture do you foresee getting automated and can use AI help?
I think there's quite a bit. And I think that you would characterize initially, and even maybe permanently, that you're going to have production assist. Is that you're going to have this ride-along program, so to speak, over your shoulder saying, all right, you're doing that again. Let me help you with that. Do you want me to do that again for, the rest of these similar spaces? Well, yes, I would like you to do that. Yeah. And
can you explain with example so that people can understand?
Sure. Okay. Example. You have doors in a project, and it would be at some some point in time, I think a fairly easy exercise for AI to look at all the doors that you put in all of the walls styles you've put them into, and begin to draw conclusions based on, well, you've got 242 doors that are all on a similar corridor wall, and it seems like almost all of those corridor walls have a rating of 90 minutes. I think that given the situation that this door would be also that same. Would you like me to, add that data to this door? Okay, I think that that's pretty reasonable because the door is inserted in a wall that has data, right? Now, where it won't help is saying, I think you think this, because it won't know that, right? Hopefully, we're not going to hit a randomized button that gives us a design that we are crafting totally the architecture and the art of that building. So that's challenging. Now, AI can assist generatively and optionally, meaning give me a whole bunch of options to look at real quickly with this. Easy. I think that as we input, I think that you would also be able to do something like this. You've placed that window and it is directly on or near the intersection of these other materials. Given the details that you've already called out, I think that if you had placed it two inches to one side or the other of this intersection, that it would be much more constructible. I think that that's possible. That would only be possible if we've trained it to understand what our wall styles are above and below any situation. But if I've been able to learn it, I know that the AI can. Mm-hmm. You wouldn't place a window that is at the intersection of materials that's challenging to control, given the construction techniques. Mm-hmm. And so I think that that's something that you would be able to do. But again, the amount of data to understand how that works is vast.
Yeah, I mean, I cannot imagine how you train an AI model, which it has to be accurately knowing how these buildings work. And we're talking about actual objects. Of course, there is computer vision techniques you can use to train models, but these are complicated systems that has to come together. So you have to not only have the actual object detections, you also have to have that situational awareness and then the surrounding awareness of other objects, for example windows in relation to walls and doors in relation to walls or bedrooms. So that's a little bit more complicated to actually train AI model, but I can see the benefit of it in day to day. And I mean, once you train it, then it's easier to get so much more information out of it and then pass it along to other teams from there.
I think it's super complicated if you were going to say, well, I think the waterproofing would be a lot more easy to do if you actually shifted this an inch. I don't think it's going to get there very quickly, because then it's going to have to understand the methodology of your waterproofing system, as well as the location vertically or horizontally of a window that you've placed. But I think it can see, in general, I think you're too close to this other system. You may want to check that. I think we can get that kind of an assist.
Yeah, I think with the spatial relationship, that is a possibility. But I still feel that, with text-based, because right now with the ChatGPT and all the other LLM models like Gemini and Claude, they are really good with text. They are getting multimodal, where you can have audio and videos and images. But specifically, if we're talking about construction drawings and we're talking about 3D models, I don't think they're there yet. It's going to be a long time since we can actually have a large model to be trained and can use this, unless you think that that's possible.
I don't know enough about how, because I think what you're getting is that the language model necessary to do construction is a different model than your normal language. And because of what we do to call out things, and the reason we call things out was to save space. Right? So we can only have so much room on a sheet of drawings, so that we've changed all of that. So probably what we would have to look at again is a way of changing how verbose that we used to do things and how verbose we could. Right? So we talked earlier about how the supposed construction interface for BIM could give you different styles of of looking at something in 3D that has to be built based on who's building it. In that case, you could actually, at that level, be able to change the verboseness of the callouts, right? And at some point in time, who cares if it's 3 lines versus 2? The guy that's building it's going to be able to understand, be able to digest that information in different ways, right? It could be completely verbose, no abbreviations, no nothing. Or maybe the guy's been around for a long time and just wants the abbreviations because it's easier for him to read. I don't know. But I think the system that ultimately we're talking about can do both.
Exactly.
Yeah, and I think that's really what we have to look at is like, why did we do this in the first place? Why do we call things out in this way? Well, because somebody's got to draft it.
Yeah. Plus code requirements and stuff, right?
Yeah.
So I know earlier in our conversation that you touched on BIM with coding. Could you elaborate on how you actually use coding and which language are we using, and then how is it actually helping you save time in a way?
So there's a lot of different ways to use programming in order to do specific application, right? So in one case, like at our company, we've written an app that says align this beam with this sloping surface above, and so it's able to find that surface, and then it aligns the beam, understanding what the original end points of that beam were, so it's exactly where you want it to be. So that's a shortcut in essence, right? It saves time because what you can do in 20 seconds could take you 10 minutes because you have to craft lines, do construction lines and add a plane and align and all that. We write that application as an add-in in Revit. We have to use .NET language, and the .NET language of choice is C#. You can also use VB.NET, and you can use C, I think. And those allow us to add an application and a button into the Revit menu. There's also a place to develop using Python. Python development is used, generally speaking, inside of Dynamo or inside of Grasshopper.
Yeah.
And if you use an app add-in called PyRevit, then you can use their interface, which gives you a shell which you could dump Python code in and have it do something immediately.
Yeah. And for those people who don't know what Dynamo and Grasshopper is, could you explain?
Dynamo and Grasshopper are visual programming languages. They allow you to gather visually nodes that have specific sub-functions to create a program, so to speak, diagrammatically. So a node could be gather all walls. And then another node could be not gather all walls, but now you're going to need to further filter, right? And you could have a node that does that. And then a lot of it's list. Ultimately, we deal with lists. Yeah. But those visual programming languages allow you to do activities very similar to how you would write an application in C#. It's very fast.
So is it like a workflow? Like this is what you need, number one, and number two, it goes from one step to another, and then third step, and then it finally gives you the output. From input to output, you have the workflow.
Yeah. I think if anybody's ever done any program, you can imagine that you'd say, do this, then do that, then do that.
If
right?
and else. Yeah.
If else, loops, all that kind of stuff, right?
Yeah.
So in visual programming, you would have a wire. It says, take the output of this node, stick it into this node,
right?
Do this, then on the output of that node, put it into this node. So it's a progression, and it's visual. So you really can see it, and you can debug it very quickly. You don't have to know coding to do visual programming. That's the advantage, and it's very accessible. It's challenging to implement on a large scale because Dynamo and Grasshopper graphs tend to be crafted individually, and to sort of distribute them to the masses is much more clunky than it is to write an app and stick it in the toolbar.
Yeah. All right. I know that we're running out of time, but I have like two more questions for you. One is, It doesn't have to be AI, but what specific technology are you most excited about? Because now you have been in this industry for more than 20-25 years and you've seen so much, and I'm pretty sure you are on the cutting edge most of the time. So any specific technology, whether it be AI, 3D printing, any specific thing in BIM, you are most excited about?
I think one piece is the world getting smaller and the desire for the world to read each other's drawings and models in the same way. And I think that's where you see standards like Open BIM, National BIM Standards, ISO 19650 coming into play. And where we get with that, we can give us the ability to trade information much more quickly and easily between projects. It's also going to allow us to train AI much more easily.
And can you give an example of that, how you can use it?
So if I've created my model, especially on the architect side, every category, every component can have a Unicode value that says that this is a interior wall of this type, has Unicode value of whatever. There's a standard for that. And on top of it, the name that we give that wall and the data contained within can be organized such that your data is organized the same way as the next architectural company, or close enough so that if anybody just walked up to that model, they could actually dig into it very quickly in order to get data. And someone might say, well, they don't need to because they don't work for us anyway, and why would they ever do that? Well, the person that would do that is likely to be working for the owner who paid for it in the first place. And that person really wants to know some stuff. And if that entity that they're working for hires 10 different architects a year to do TI work, large building work, they need their ultimately their facilities database to gather data efficiently. So they need everybody to give it in the same naming system. And so that's a fairly overgeneralized example, but that's, I believe, where we're going to go. I mean, I'm excited about it because that could solve some of the nagging problems I see in the industry, which is recreating the wheel all the time. So some of you out there may have drawn a door detail at some point in time in your career. Well, it's been done a million times, and it doesn't really, in most cases, a door detail of a door jamb on an interior partition wall with 5/8 jip either side of a metal stud been done about 1 billion times. And yet somehow, some way, a lot of architects find a way of redrawing that detail. Why? I'm very much excited to see that kind of thing go away.
Yeah.
The systems that are coming to us soon are going to be really helpful.
That's awesome. That's really cool.
Yeah.
So my last question to you is, what advice would you give to the people who are just starting off in BIM or in architect or in construction, and they want to use the latest technologies but also want to find practical usability of it, and then also want to save time? How do they approach about these technologies that are advancing so quick, and how can they learn from it?
Well, Revit really isn't changing that quickly. So as a base, understanding Revit and why it's used and how it's used is safe, right? At this point in time, I believe that Rhino and Grasshopper are safe also because they're only gaining in popularity and they're being used by many of the architects. So you can that's safe. Dynamo is safe because it's within the ecosystem of Revit. A lot of the other things that are surrounding it are more subject to change. And those things are visualization tools. They're going to change with AI. And a lot of the thermal computational things that you can do very quickly to a model, they allow you to do thermal reviews of your building. Okay, stuff like that's going to change with AI. It doesn't mean it's going to go away. So what the common thing there is understanding AI. I would say get involved with how to prompt AI because that's not going anywhere. at least maybe for the next 5 or 10 years. Somehow, some way, we have to prompt it to get what we want. Find out how to do that well. It's sort of like 10 years ago was finding out how to do Google searches really well. There is a way to search Google more efficiently. It's going to be the same thing with AI, and it's going to affect all the software eventually. So that's safe. But really, the core in building industry is Revit. Understanding how to use it is important.
Yeah, that's a really good advice. I can definitely foresee some sort of like prompt engineering inbuilt in most of the softwares we use. For example, Revit, AutoCAD, Bluebeam, Rhino, Grasshopper, anything you can imagine, you will have some sort of prompting. And so while everybody is already learning these basic tools, why not just learn prompt engineering that will allow you to be on the edge of and have the competitive advantage. Kevin, this was a pleasure. I've learned so much from you. You definitely have a lot of wisdom when it comes to being in BIM, being in the VDC and construction and architecture realm. Thanks a lot for blessing us with your presence, and good luck for the future.
Thank you. It was a pleasure.
Thank you. Thanks a lot for listening, everyone.